For coming in, I've got one of the great times for a presentation. It's like the last one of the day, which I don't know if that sucks worse than the ones that are Saturday morning when people are hungover or right after lunch at any given day. So thanks for coming in to at least kill a little time before you go to slide show roulette. And I will try not to kill any more brain cells than you may have already done at the bar. Last year we managed to not drink them out of all their alcohol. We did 2 years ago, so the challenge is still there. So if you haven't tried to help at the bar, at least go make some donations to Hackers for Charity. I think that's all my public service announcements. So, I am Travis Hartman, and I'm presenting on electronic safeties and firearms. So I always have to avoid any statements or claims. I may own or have built multiple firearms. I'm not a spokesperson for any company. Yes, I have equipment from Craze and whatever else that I work with, so just bizarre stuff. Anything I'm talking about in terms of electronic safeties, they may not be appropriate for all users in all situations. That's something that a lot of the industry has had arguments, debates, name-calling about, because they say, well, in this one situation or whatever else, and absolutely I don't want it. Well, fine. Let's get to the point where maybe you have an option to have it at some point. There we go. One thing I have learned is that you have to have ponies or something, and this is the closest thing I can come up with a pony and a firearm. So I have now checked that. I do have 3 pony slides throughout the presentation because there was a 3 pony minimum. I don't know. Take it up with Dave. So, smart guns. If you watched any movies, the 80s, the 90s, last decade, you've probably seen some sort of smart guns. Anybody see Judge Dredd with Stallone? And the lawbringer, the lawgiver, and he's like talking, grenade, full auto, double whammy. Okay, that's when I heard smart guns. Oh, that's pretty cool. But what's actually been offered out there is stuff like, it's a magnet ring, something like Cracker Jacks have. Almost every solution, it's single factor, it's weak authentication. Prices typically are going to be 50% more or maybe double the price of just the firearm alone. And a lot of times it's reduced functionality that it's including. A couple of examples that we have here. This one, the magnetic ring. So it's a really high-tech solution. You have to have a ring that's a magnet, and if you put your hand on it, it'll let you fire it. Or in that case, you have to put your hand on it, move a lever, and then it'll stay unlocked until you put a ring with a magnet and move it again, and then it would be locked again, because that's much quicker and much safer than somebody just flipping a lever with their thumb. Anyway, the one in the lower right, that is the high-tech approach, and it's by a company called Armatix. It cost about $1,399, and the watch, which actually does have a fingerprint sensor and looks extremely geeky, is another $400. So rather than somebody going out and spending $400 to buy a semi-automatic handgun, they're now looking at $1,800. Because anybody that buys a firearm definitely has an extra $1,400 laying around that price is no benefit or no issue. Another solution that's out there, it's called the Kodiak, and it provides a retrofit. So the Colt 1911 format, really it's a 100-plus-year-old design. This is replacing the grip frame, or the grip on it. It uses the same grip frame, but it's adding some biometric authentication. Once again, it's about $400, a lot cheaper than the Armatrix solution, but still, it's just that. And something that's bothered me whenever I looked at all these things is it's always the firearm company or whoever the manufacturer is, they're trying to address everything. They're saying, okay, I'm not just going to address my firearm manufacturer, I'm going to address the electronics, I'm going to address the security in the electronics, I'm going to address the interoperability. And working with the other people I've been involved with, that was something that really rubbed us the wrong way. You go to any of the sessions and you talk, people are, they're looking about whether it's stuff that's in the network in your house, or your refrigerator's talking on the network, or car system. There's a lot of very smart people, and I'm sure there's a lot of you in here that have different ideas or different approaches to the way you might do a smart gun implementation. So the thought we had is, why don't we take a look at this, look at the problems, see how we can break that apart, so that we can actually provide a platform so that you, or you being the royal you, can have the ability to go ahead and design your own electronics module and have a way to just plug it into a common type of a firearm. So I'll get to how we're going to do that. One of the issues out there, and the biggest thing that's been stopping smart gun adoption in the U.S. has been the New Jersey law. And this law has been around since, I believe, 2002. And what it says is if any smart guns are for sale in the U.S., anywhere in the U.S., then that starts a clock running. And within 3 years, all new handguns sold in New Jersey have to have smart gun technology, which is kind of weird. They don't care about how good it works. They don't care how reliable it is. They don't care if it's actually available in their state, but the law gets triggered and it starts that happening. Also, we've seen a lot of manufacturers having to individually absorb the costs and risks of research. So if one manufacturer says, hey, I'm going to deal with this, I'm going to offer a smart gun, Armatix has tried it, a couple other companies have tried it, and pretty much what happens is they get shut out by special interest groups. They'll be picketing at any stores that carry their firearms, and it turns out to not be well for them. Colt, I believe it was, had a CEO asked to not return after he talked about possibly supporting smart gun research. Okay, the second mandatory pony picture. It's pink. Got a little statement from Beretta. Beretta was looking at firearms, and this is back in '99. This was the last time the firearms industry really started to take a look at that. And what they basically said was some of the proponents for smart guns were looking at it as an alternative way to keep things protected. And they're saying, well, if you've got a smart technology, it's okay to go ahead and keep a round in the chamber, keep it loaded. You don't have to do any of the other stuff you're doing, like maybe keeping it in a safe or doing other locks. So that was an issue. And so, 99, 15 years ago, that was when they last looked at it and said, it's just not there. Well, I think miniaturization, the state of technology has advanced a little bit since Windows ME, although I know organizations are still using Wins. And so why don't we take a look at what we can do with that? Has anybody in here heard of the Smart Tech Foundation? Okay, cricket. So there is an angel investor and advocate for gun reform named Ron Conway. He is the main backer of the Smart Tech Foundation. They've awarded $1 million in grants to foster innovation or foster new things that are going to be happening out there with smart guns. The first one, they had the competition earlier this year. There's been one grant that's been announced. There's been a bunch of the sorry you weren't selected notifications that went out. I really believe in the next 12 to 18 months what they're doing is going to lead to sales in the U.S. The picture there on the right, that is a 3D printed gun. It is not designed to actually fully fire, but it is designed by a 17-year-old in Colorado. He's saying his biometric sensors got 90% accuracy. Well, he doesn't say is that where his crossover error rate is that false negatives, false positive. He doesn't say anything about that. It's just 90% accuracy on the sensor is what he's claiming, and he's getting pretty close on the design for all of the parts. What he can do is if he gets his FFL license and even sells the design in the U.S. to somebody else so that they could print out their own parts, that counts as a smart gun sale, and that will trigger the New Jersey law. So something else would need to happen. The industry is going to have to look at something different so they can actually have a challenge to the New Jersey law. So, been working on a framework. Got 3 different components to that. One for the hardware. What are we going to actually do to that chunk of metal, the thing that lets things go bang and fly out at high speeds? What are we going to do for the electronics so that we can actually control things in that? And the licensing. How are we going to make this so that it's going to actually work for the manufacturers, or it's going to work for the, I'm going to generically refer to you as the hackers or the people that might be doing something with the electronics there. How are we going to be able to help all those groups be able to work together? The first thing we've been working with is the AR-15 pattern. So everybody has seen, I'm sure, an AR-15 or an M16 or something. It's the scary black gun. But the big piece, the part with the serial number, is the lower receiver. And that is the part that is regulated. That's why you have to have the go through the background check when you go and buy a new one. But a nice thing about that is it also has these, it's the pistol grip, which in and of itself isn't terribly scary, but it does have some extra space. So it's hollow in there, there's not any moving parts, and that's going to give us a place where we can actually put electronics, and as we continue to work on getting things smaller, but it's a lot of free play area. And so if people are saying, I want to be as a hobbyist, go out there and interface with what's going to happen in the rest of the firearm, why don't I take something that's got the most space and be able to work with that rather than start with something that's really tight like a semi-automatic pistol. Some of the things we need to have a servo or a solenoid. Most likely it's going to be a latching solenoid. It needs to be able to interact with the disconnect, the trigger or safety or some other component in there that actually prevents it from firing. And since we're not designing firearms, but we have to be able to transfer the dimensions that we've come up with to other manufacturers. So we have reference points based off the standard mil-spec design, as well as the pistol grips. The grips will have to be slightly redesigned. If you go up to the people working in the makerspace upstairs, they'll say something like this will take them about 4 hours to print out, depending on the complexity. But most of what they're printing isn't going to have the structural strength to be able to handle the little bit of impact it's going to get from the recoil. So they said you'll have to print it, then you'll have to make a small mold, then you'll have to be able to cast that. All stuff you can do at home, but it is going to take a few hours, probably a couple days' time or a weekend time. All right. Anybody in here taking the time to cut an AR in half? Oh, okay. Has anybody explained to their spouse why they're buying firearms so they can cut them in half? Okay. Guess how well that was received. Yeah. So, and she said you've not even been to the con and started drinking, so I don't know what you're doing. But this is the basic design on what's happening with the AR. So this channel, the long channel you're seeing right there, that is where there is a bolt that goes from the grip area into the lower receiver. This is the trigger. This is the safety. The safety prevents the trigger from rising until it's rotated and it's got a notch cut into it. And then the trigger can rise up into that area once the safety is turned into the fire position. So like somewhere in there is what we have to be able to interact. The closest structural thing that we've been able to work with is a channel right there. It's going to be a hole that's drilled. We'll be providing 3D printable jigs. So if you take an AR, you can print the jigs, you can center the hole, and you can take a drill press or a hand drill, preferably a drill press, and drill your own hole in an AR, and then you'll be able to practice with the electronics. Essentially what's going to happen, it will take also a slight modification to the back of the trigger. But the push rod will rise through the channel, engage with the back of the trigger, and due to the rotational direction, that's essentially going to be perpendicular to the rotational direction of the trigger, and it will prevent you from being able to pull the trigger. Okay, great. So I drill one hole, maybe have a slight modification of the trigger, and now I can start doing things with the electronics. We will pass those dimensions over to any manufacturer that wants to use them, because I can't give out the entire AR lower receiver dimensions. The ATF says that would be disseminating or selling a firearm. It comes in the international trafficking and arms regulations get triggered with that one, and I really don't want to get my house raided. So what we will do is provide the jigs, so if you want to modify your own and work with it, great. If you're a manufacturer, we will provide the dimensional specifications so that you can do the offsets and incorporate it into your own milling designs. So looking at the PCB, typically designing the printed circuit boards, it's got a steep learning curve. Doing it in small volumes is expensive. We'll provide that information, but most likely we're going to provide a reference board as well. So you'll have some ability to take, the reference board will be looking at probably an Arduino, and that way you can have something that's fairly easy to work with. It's not the most power efficient way to do it, but nobody's having to learn assembly language that way. And I was told I'd get bonus points if we have the make a jab at a CISSP, so I've included that one in there. Onward. Great. You can all read that schematic, right? Excellent. Perfect. So what we're going to do is we're going to take that's what we've got a lot of the initial design with. But anyway, we take that, run it through another package. That lets us lay out the circuit board, what has to go where on the circuit board. Don't worry, we'll get stuff on the website. You'll have access to it. Or you can just look at pretty colors. But you're able to look at the different components there. Right now, this one is about 0.7 inches wide, 1¼ inches tall. Spaces for LED indicators, so you can have it indicate it's locked, it's not locked. I like having 2 colors flashing, whichever. Room for the microcontroller, voltage regulator, and then the battery and the servo. Most likely, it's going to be an Arduino Pro 3.3 volts that's going to be used. One question we have, and this is something I'm really happy with where technology is now. The power, and that's been a big pain in the ass as we've been trying to figure out how to do this. In general, if somebody's saying, well, I'm going to have a firearm or a police officer in the vehicle, they've got their service rifle, and nobody wants to go say, okay, at the end of the day, what do you have to do? I have to go home, I have to plug in my phone, I have to go plug in my rifle so that I can unlock it tomorrow. And because then I'm sure it'll start being all those other things like, damn, where'd I leave the rifle? Is it in the couch cushions? It's 3 a.m. I try and answer the rifle. It's just bad things that happen with that. So that's a real concern. But with the wireless charging, and there's definitely been some advances with that. So if it gets to where they can say, using the police officer example, when they put it in the vehicle, if it's charging right next to the handle, and it doesn't actually have to have physical contact, but it's charging the surface charging, awesome, cool. Maybe somebody in their gun safe, when they put the rifle away, it keeps it charged. And because you're not running this with the processor at full load all the time, you're going to get a few days battery life out of it. If you're using something other than the Arduino where you're actually dealing with a different microprocessor, you can get a lot more battery life. It's going to just take some more time to figure out in the programming. What would be good, though, is you can work with the basic reference board we have, come up with the sensors that you want to incorporate, figure out the form factors, do those type of things, and then transition from that into something that's going to let you have a little more power maintenance and management with that. If anybody's not familiar with the CR123 Alpha, I know somebody is, a man with a beard, excellent. So it's a little shorter, a little fatter than a AA battery, and it lasts a lot longer. Okay. So looked at some of the different options we have with the electronics. We're working on the reference board. We're going to have a USB for wired connectivity. We're debating on whether or not to do a Wi-Fi or a Bluetooth, give you that option for the wireless as part of the reference. Any preferences from the people here? Wi-Fi, Bluetooth, don't care? Okay, awesome. Okay. Okay. And the nice thing with the reference board, if you don't want to enable it, you don't enable it, or you don't have that part soldered on there. But I appreciate hearing multiple people saying the same thing, because that gives us an idea or a direction that we need to go. Then we're actually looking at the grip itself. If it's got a USB connector, where is that going to need to be? That's probably something that, because we'll release the grip files, so you can modify that as well. It's going to have a couple things that are going to be pretty static, which is the hole in the middle and the mounting screw locations for the circuit board. But other than that, you can change the outside shape, change where you're like, well, I got the LEDs, but I want to have it on the back of the grip, or the side of the grip. So you can always run a short wire and place it somewhere else on there. One thing we wanted to have, as we're looking at this, like, well, okay, whenever somebody's unlocking it, we don't want them doing the Luke Skywalker lightsaber thing. We're like, well, if I look down the barrel and try and press it, that seemed like it was going to be a short-lived approach. Okay. So licensing. This is the part where we think that we might be able to actually get some manufacturers to have buy-in. Licensing's free. They don't have to pay anything for it. Much like open source software licensing, If you take technology from this, you do further development on it, you just have to release it back out to the community, let them to continue to develop with it. The one restriction that we want to have in the licensing, any components that you're saying they're compliant with the framework, you're not allowed to sell them in a jurisdiction where it mandates the use of smart guns. That create an interesting challenge in New Jersey, because if the manufacturers that sign up for that, then they can't be sold in New Jersey, so state law is interfering with interstate commerce because of a private contract, the license itself. I'm not sure how the lawyers would settle that one, but I think it would be an interesting challenge there. But also, if manufacturers are looking at it, even if they say, you know what, I'm not going to do anything myself, but I'll at least agree with that licensing or that framework, that'll provide a little more support, more opportunity for people to go out there and look at the different things that they can do, that you can do, and come up with different technology. Because really, I would like to see somebody in 5 years and say, you know what, we took this basic stuff, and now you can go get the open source references and you can build your own lawbringer. So future goals, want to continue to refine the components. We're pretty close, you saw from the CAD files, on what needs to happen with that. I hope within the next few weeks we can get a grip reference design. We're still working on exactly how we want to have the layout of the PCB. I would guess that a reference PCB in small run is going to be in the $150 range, including the components populated. At least that's the target right now. So we're looking at doing that, not making any profit on it, but being able to get it out there for people to actually muck with. Because mucking with things is a very good term to use with firearms. If anybody's a lawyer, has a friend that's a lawyer, or would like to be a lawyer, we're looking for help with getting the licensing wording in there. We've got some legal support on that, but everything we'll be doing, it's been self-funded. It's been us in our spare time, and even our legal support, it's been people that have been volunteering. So any additional stuff you can do with that would be awesome. Product testing. If you say, you know what, I don't want to actually mess with the circuit boards, but I'd be happy to test the jigs. I've got this extra AR. I know it's not going to violate anything structurally. It'll be hidden by the grip when the grip's installed, so nobody will see it. But I'll make the contribution to the community of taking a half hour of drilling a hole and just seeing if some parts will fit. That would be a huge thing. Typically, for me to get a lower receiver that's got cosmetic blemishes, whatever else, I'm paying $60 plus a little bit for shipping plus the firearms transfer. And that adds up pretty quick. Okay. So I had to have my third pony thing in there, so I've got that. So please say hello to my little pony. If you need to reach us, there we go. So multiple ways to reach us: Facebook, Twitter, email. If you wanted to use Wicker, that way you can have your messages delete themselves after an hour or whatever time period, so you have plausible deniability that you ever talked with us. You're more than welcome to use that. I've got some business cards up here that have all that contact information. You're welcome to grab one of those. And so I'll open up to any questions, and if I don't have any questions, I do have a good quote from General Mattis. Yes? Yes. So the grip itself, no. Of the aluminum of the lower receiver, the way it's positioned, the answer is it's not supposed to. And so my engineer, who's designed several lowers or done custom ones for a few different companies, he's assured me that that's going to keep everything there. As with anything else, when the engineer tells you it's completely safe and it's going to work, I'd love somebody, some people besides me to field test it. Yeah, and you know what? If you're in North Carolina, I live in North Carolina. I would even take one of my lower receivers after I get the hole drilled in it and say, here, go put it together, go shoot it at the range, smack it around, do whatever you would normally do with it to see what happens. But for the most part, it's not in. They make some lower receivers out of plastic, because it's not a high impact area. it doesn't receive a lot of the stresses. The upper receiver, it receives stresses from the firing. Lower receiver, it's pretty much just holding everything in place. So, all right. Any other questions?
I was more concerned about the integrity of the trigger.
So it's at the very back of the trigger, underneath the safety area, so it's just a small notch in the bottom of it. And the only thing that would be weakened is if, like, you're a 900-pound gorilla and you're still trying to squeeze it up into the safety area. But the angle of the hole is perpendicular to the curving path of the rotation of the trigger. And so that creates a shear force between the pin and the trigger itself. The pin should not be able to shear because of the way the wall is reinforcing it. And the trigger, it's got a lot of material that would have to be able to break through, which at that point I think you're probably going to do damage to the trigger pin itself that's the trigger rotates on. And the blue shirt with the Spartan there.
I was wondering how you plan to combat like static shock to a metal frame gun or a electronic pulse to a metal frame gun with the board inside, with the electronic all of.
That's a great question, and I look forward to people that are working with it coming up with great answers. I just want to make it possible so people can go start working with it. And because if it was my car and I want to go tinker with it, I can go buy lots of things and I can tinker with it and I reprogram. For the thing that goes boom, I haven't had an ability until now to do that. And there's somebody way in the back. Yes?
How do you plan on handling the cleaning oil getting on the circuit board, either corroding or pouring out?
So the only connection between the receiver and the grip frame itself, well, actually there's two. One's going to be the push rod, and one's going to be the grip screw. Typically, you're not seeing much come down through the threads on the grip screw, and I think it's going to be a minimal amount or nominal amount that would actually be able to make it through unless somebody's trying to drip it right on the push rod. I will push that question back to my design engineer, and he'll say, that's a great question. We probably need to test that for a few thousand trigger pulls. Yeah. White shirt, yes. Yes. We were actually looking at having a small circlip that would just provide just a little bit of spring force that would help it disengage from the trigger if needed. Well, it would make it easier to disengage, but by looking at either a servo or a latching solenoid, unless it gets power applied to it, it's not going to move from either position. So if you have it unlocked and the battery died, it would tend to stay in the unlocked position. If it's in the locked position, the battery dies, it tends to stay in the locked position. And that was one of the things that between the electronics guy and the CAD arguments being back and forth, like how do we do this? Make sure do we have to have a cam somewhere, or we the sheer strength of the pin, so that if it was just a direct line movement for everything, with a solenoid that's not powered, most of them you can go ahead and push the rod either direction. Okay. All right. Time. All right. Thank you all for your time. There is the slideshow roulette upstairs. Yay.